right, I think it's working. All right, here we go. We scroll up here. We are in Chapter 6, Section 5. We're going to be analyzing graphs of polynomial functions. Okay? We're going to do problem number 1 together. By the way, your calculator might need to be reset, so you might need to hit second plus 7, 1, 2, because we've been working with sine and cosine waves in my other class, and your graphs are going to be messed up. Right now, hit y equals. Our function we're going to type in is negative x to the power of 3, or also known as x cubed. And then we have plus 3x squared. And then we have a minus 3. All right? So after you guys type this in, you can go ahead and hit the graph button, take a look at it. Now there are some functions in the newer calculators that helps you be able to look at this and analyze it a little bit clearer. All right? One thing I would like you to do is I would like you to go to second zoom, and I would like you to turn the grid line on if you have one of the newer calculators. If you don't have a newer calculator, you can just put the grid dot if you want to. All right? Now I hit graph, and what do you notice is on the screen? Grid lines. Okay? Now another thing, if you ever wanted to, you see how these look like little rectangular blocks, not squares? If you wanted to square things up, you can hit zoom and hit the number 4. And now you have an even clearer picture of that graph. Alright, so I'm going to take a snapshot of this. Okay? Now, on your paper, what I'd like you guys to do, we're going to fill in the x and y table as you guys look at it. All right. Right now, in your table, if we were to go back to the paper, all right? Right now, we start at negative 2, and we're going to work all the way down to what, a positive 4? So here we go. We're going to go from negative 2 all the way down to a positive 4. So at negative 2, what's our y value at negative 2? 17. Okay. Negative 1?
1.
0?
Negative
1?
1. Oh,
Negative 1. Okay. 2?
1.
Negative
3?
Negative 3.
And 4 is way down at a, was it negative 19? Okay, negative 19. Now, obviously, you guys can't put all of this on your graph for problem number 1. But I want you guys to carefully realize that you can accurately graph from here to right here. This is the part that you can accurately graph. So when you guys are doing this, I'm looking for accurate graphs, not perfect graphs. All right? So I'm looking for a what? A negative 1. I'm looking for this point. I'm looking for 0, negative 3. I'm looking for a 1, negative 1, a 2, 1, and a 3, negative 3. So we're going to kind of work on how do we take these points and make a nice, accurate graph. So I'll go back to right here. We're going to plot these points. So negative 2, I can't plot because that's way up at a 17. But negative 1, I can plot. That's at a 1. So if you guys would, negative 1, 1, put it right there. 0, that was at a negative 3. So put 0, negative 3 right there. 1 was at a negative 1. 2 was at a positive 1. 3 was at a negative 3. And that's kind of the last one you could actually plot, because once you hit 4, that's way down at a negative 19. All right? But as you're doing it, this is at a negative 2. Negative 2 is way, way, way up at a 17. So as you draw this in, make sure you don't cross over that negative 2. Make sure you're coming down. I'll do it in red. You're coming down really steep. Okay? Really steep down through this point. Okay? Try to do a better job of that. Try to get a better perspective. Then it bottoms out right there. Okay? Goes back up. Goes through that point right there at 2, 1, and then it drops very steeply down through this point And you're trying to do the best you can to mimic what we just did in the what? Did in the graphing calculator, all right? You're trying to use your estimating skills and you're plotting the points you can actually plot accurately, all right? Now, what I'd like you to do is after you guys do this on your paper, okay, what I'd like you to do is I'd like you to make a sketch right now of this in your journal right now. So go ahead and make a sketch of this. We're going to talk about some points that you're going to have to know how to label. All right, right now what I'd like all of us to do after you copy this down in your journal, we're going to analyze this graph, and I want you guys to label some things, okay? Right here, I'm going to put a green dot right here, and right here. I want you guys to understand those are all considered to be the real zeros of the function, okay? The real zeros are also known as your what? Your x-intercepts, also known as solutions, okay? Those are all the same word. So right now, how many real zeros do we have? There's 3. Now listen, in answer choice, I'm going to scroll down just a bit. In answer choice B, it says, I'm going to read it out loud here, it says, determine the consecutive values of x between which each real zero is located. Now, I'm not asking you to find the exact zero, I'm saying right now, our first zero is located between a -1 and a 0 on the x-axis. So your answer choice for B, you're going to write between -1 and 0. That is where one of the real zeros is located, between the x values of -1 and 0. I'm going to label this as a 1, this is a 2, this is a 3. Where is another real zero located? Right here. Where is that between? So you're going to write between 1 and 2. And finally, the last zero is located between what two integers of x? 2 and 3. 2 and 3. So that's all I'm looking for. When it's asking you to determine between what consecutive integers the zeros are located, I'm just looking for what they're between, not the exact number. Okay? So that's your answer choice for B. Now, we were able to locate that on this graph because this is an accurate graph of the drawing. You can also locate them in your table. Let me show you something real quick. Let me highlight it in green. Can you guys see that between a 1 and a -3 right here, a 0, the number 0 is located, your y value is equal to 0 between a 1 and a -3. And that's between what? -1 and 0. I'm going to highlight another one. Right here, can you guys see right here? A 0 is located between a what? -1 and a 1, so that's another 0. So you can look at your table and say, hey, that's between a what? 1 and a 2. And the last one, got to highlight over a highlighted area right here. That's kind of hard to see. I'll change it. Can you see that one between the 1 and the 3? That's the last place where the y goes from a positive to a negative, and 0 is located between those two numbers. The last answer right here is between a 2 and a 3. So you can also use your table to figure out where it jumps from what? Positive to negative, or where it jumps from negative to positive to locate between what integers they are.
So you just find every
Goes from a positive to a negative, or from a negative to a...
so find every actual zero.
Yeah. Okay. Now, the last thing we're going to talk about, okay, you'll look at your paper, it says max and min. Max is short for maximum, min is short for minimum. Okay? So right here, if you guys would in your journal, put a little arrow here. I want you to call this the relative maximum. Call it the relative maximum. It's not considered to be the absolute maximum because this graph goes up forever. Okay? And this one right here, this is referred to as
The one do that. That will occur.
yeah. So it bottoms out right here, right? So that's referred to as a relative minimum. It's not the absolute minimum. The absolute minimum, there is none. It goes down forever. Okay? But the relative minimum right here occurs the relative minimum occurs where x is equal to 0. Yes, this ordered pair, everybody, is at a 0, -3, but the relative minimum occurs where the x value is equal to a 0. What is the x value? Not the y value. Where is the x value? We're at the relative maximum.
2.
At 2.
So you just put x value.
Yes, I want to know what the x value is for the relative minimum or maximum. Yes, the ordered pair, Luke, the ordered pair is at a 2, 1. And yes, it does, the y value is at a 1, but I want to know the x value. Okay? Now, before we finish this video, I want you guys to understand what an absolute maximum is. Okay? If you have a graph, okay, that goes like this. Okay? If you have a graph that goes like this point right here would be referred to as a relative maximum. This point right here would actually be considered the absolute maximum. And this point right here would be considered
So why would you have a relative maximum and absolute maximum?
that is absolutely the highest point that it absolutely gets.
But you can only get that.
Whenever you have different curves. Whenever you have a curve through a polynomial function, you have turning points, okay? By the way, this point, and this point, they're all considered to be turning points in the graph, okay? It's where the graph either goes from rising to falling or from falling to rising. Now, what if I change something right here? If I change this graph, and I didn't put the arrow going down for ever, and I made it go back up. Guess what? Now that's no longer an absolute maximum. Now that's just a relative maximum, because technically there is no max. That goes up forever, okay? So make sure, go backwards here.
Question, would you always use the relative maximum?
If it asks you for a maximum and if there's more than one, yes. So basically you're just looking for all the either the absolute maximums or relative maximums. Okay? Now, is there any minimum? Is there any absolute minimum in this graph? No. So you would say there is no absolute minimum. Okay? Now, one more graph. Let's say you have something that looks like this. Okay? So what I'm doing, I'm going to label 3 points here. I'll do them in green. We have this point right here. We have this point right here. And this point right here. So I'm going to put a little arrow to each of these. See if you guys can label them correctly. All right? What do you guys think this point right here would be? Absolute. Good. That's the absolute minimum. Okay? What about this point? Relative minimum. And what is this point? Relative max. Very good. And so we would put, there is what? There is no absolute maximum. Okay? So if you guys want to jot that down, it's kind of a way, how do you identify these turning points in the graph? That's how you can identify them. Okay? And I'm always looking, where is the x value when this is happening? That's what I'm looking for, where the x value is.